Let's visit Norway Way, which has constructed a crucial, underwater project called the Ormen L gas pipeline spanning an impressive 1,200 kilometers. It connects the Ormen L field in the Norwegian Sea to the United Kingdom, specifically to the processing plant at Momna, Norway, commissioned in 2007. This pipeline plays a crucial role in securing energy supplies in the region, marking a significant achievement in the field of energy infrastructure constructed at a cost of over $10 billion. The Ormen L gas pipeline's engineering required innovative solutions to navigate the challenging deep water conditions of the Norwegian Sea, including depths of up to 1,100 m. This project also stood out for its environmental and technical challenges, particularly the need to minimize impacts on the delicate marine ecosystem and address the harsh conditions found in the north. Let's go to the Louisiana offshore oil port, which stands as the only port in the U.S. capable of offloading deep draft tankers, situated approximately 18 miles off the coast of Louisiana. The port plays a pivotal role in the import and export of crude oil, handling about 10 to 15% of the country's domestic oil, built in 1970. The construction of this engineering feat was both a logistical and financial endeavor, costing over $300 million at the time, an amount equivalent to over $1.4 billion today. The most significant challenges during the port's construction was the laying of its underwater pipeline. This pipeline stretches over 48 miles to the onshore storage facilities and was one of the longest and most expensive underwater pipeline projects at the time. Japan's constructed Seikan Tunnel, stretching 54 kilometers, with a staggering 23 kilometers lying under the seabed. It connects the islands of Honu and Hako, piercing through the Tsugaru Strait, completed in 1988 after nearly 2 decades of construction. The tunnel resolves the overcoming of geographical isolation and enhances connectivity, with an overall cost of approximately $3.6 billion. The Seikan Tunnel's construction presented formidable hurdles, including dealing with the seismic volatility of the region. The tunnel now serves as a critical link for passengers and freight trains, being one of the few ways to access the island. While underwater tunnels are usually used for mobility, Canada is utilizing them for something else with their Seymour Capilano water filtration project, nestled in the verdant landscapes of British Columbia, Canada. The tunnel is an engineering marvel designed to ensure the provision of clean, safe drinking water to the Vancouver metropolitan area. This project is distinguished by its expansive network of tunnels stretching over 7.1 kilometers, which serve as conduits for transferring water between the Seymour Reservoir and the Capilano Reservoir, constructed at a cost of over $600 million Canadian dollars. The project underscores the critical importance of sustainable water management and urban planning. The construction process showcased a blend of traditional tunneling methods in modern technological innovations. 2 massive tunnel boring machines were deployed, each weighing over 1,000 tons, carving through the mountainous terrain with precision. The project became operational in May 2010, and ever since it has been a vital part of the region. It's time to visit the Channel Tunnel. An engineering feat that bridged the UK and France beneath the English Channel stands as a symbol of European unity and technological ambition. Completed in 1994, at a cost of $1 billion. This project was one of the most significant engineering projects of the 20th century, spanning 45 km with 37.9 kilometers beneath the sea. The Channel Tunnel holds the record for the longest undersea portion of any tunnel in the world. The construction involved the use of 11 tunnel boring machines to carve through the chalk marl beneath the seabed. This Herculean task required unprecedented coordination between British and French construction teams. The tunnel comprises 3 separate tubes, 2 for rail traffic and a smaller service tunnel that acts as an emergency escape route. The use of precast concrete linings to reinforce the tunnel walls was a critical component of the construction strategy, ensuring the tunnel's durability and safety today. The Channel Tunnel is a vital link for commerce and travel between the UK and continental Europe, facilitating the seamless transit of millions of passengers and tons of freight annually. The Baltic Pipe project was completed in 2022 at a cost of approximately €1.6 billion, and it stretches over 900 kilometers, forging a direct link between Norway's gas fields in Poland with passages through Denmark. The construction of the Baltic Pipe involved laying underwater pipelines across the North Sea, a challenging endeavor that required advanced engineering techniques. Specialized ships were deployed to lay the pipes on the seabed, ensuring minimal disruption to commercial navigation routes. This project is notable not just for its engineering achievements but also for its role in enhancing political cooperation among European nations by providing a stable, reliable source of natural gas. The next project on our list is a tunnel that's connecting two major countries, the Fehmarnbelt Fixed Link. This ambitious project, with an estimated cost of €7.4 billion, is not just another infrastructure endeavor. It's a bold leap towards uniting regions and enhancing mobility in Europe by connecting Germany and Denmark. Spanning approximately 18 kilometers, it's poised to become the world's longest immersed tunnel designed for both rail and road traffic. The construction employs the use of specially designed ships to lay sections of the tunnel on the seabed, a method that underscores the innovative spirit of this undertaking. The tunnel comprises 79 individual segments, each meticulously fabricated off-site, showcasing the meticulous planning and precision that underpin this colossal project. The planned completion date for this project is unknown, but they're aiming to open it somewhere in 2029. Now it's time for a different type of underwater project, and for that we have to travel to the United States, where the Lake Mead Intake No. 3 tackles the critical issue of water scarcity. This monumental project, costing an impressive $817 million, was driven by the urgent need to secure a reliable water supply for Las Vegas, a city that depends heavily on the waters of Lake Mead. Initiated in 2008 and completed in 2015, the project involved drilling a 3-mile-long tunnel beneath Lake Mead, one of the largest man-made lakes in the United States. This was no ordinary task. It required the use of a 1,500-ton tunnel boring machine cutting through the earth at depths reaching 600 feet below the lake surface. The purpose: to construct a new intake capable of drawing water from the lake's depths, ensuring access to clean water even as lake levels fluctuated perilously low due to prolonged drought conditions. The construction of Intake No. 3 was not just about securing a water source, it was about innovating for the future. Engineers and workers faced the daunting challenge of working in an environment where temperatures soared and the risk of flooding within the tunnel was a constant threat. It's time to visit the United Kingdom, where a tunnel is being constructed for an ambitious purpose. The Thames Tideway Tunnel aims to tackle London's over a century-old sewage system problem, officially initiated in 2016 with an estimated completion by 2025. This massive undertaking is designed to prevent millions of tons of untreated sewage from entering the Thames River. Stretching over 25 kilometers and delving up to 65 m below the river, the tunnel is a critical component of modernizing London's sewage disposal and treatment capabilities, costing approximately £4.9 billion. Project is not just an engineering marvel but also a significant environmental initiative by intercepting overflow from existing Victorian sewers. The tunnel will ensure that the Thames remains cleaner and more vibrant for future generations. Despite its environmental benefits, the Thames Tideway Tunnel has faced controversy, particularly regarding its financial impact on residents through increased water bills. It's time to move on to one of the biggest pipeline mega projects in the world, called the Nord Stream gas pipeline, stretching beneath the Baltic Sea to connect Russia with Germany. The strategic pipeline, operation since November 2011, spans approximately 1224 kilometers, making it one of the longest offshore gas pipelines in the world, with a total project cost estimated at €8.8 billion. The Nord Stream has capacity to transport up to 55 billion cubic m of gas annually and, playing a crucial role in ensuring energy security and diversification of supply routes in Europe. Constructed using state-of-the-art technology, the pipeline comprises two parallel lines, each made from tens of thousands of steel pipes welded together on board specialized vessels. These pipes, coated for corrosion resistance, were laid on the seabed by some of the world's most advanced laying ships, navigating through challenging marine conditions. Despite its technical achievements, Nord Stream has been mired in controversy. Critics argue that it increases European dependency on Russian gas, posing geopolitical risks. Environmental groups have also raised concerns about the potential impacts on the Baltic Sea's delicate ecosystem. Yet proponents highlight its contribution to energy security and lower carbon emissions compared to coal and oil. It's time to visit Norway for a massive underwater mega-project. Norway's Coastal Highway project is an unparalleled infrastructure endeavor aimed at revolutionizing travel along the country's rugged western coast with an estimated cost of $40 billion. This ambitious project seeks to eliminate the need for 7 ferry crossings by connecting the cities of Kristiansand and the south to Trondheim in the north through a continuous ferry-free highway spanning over 1,100 kilometers. It involves the construction of bridges, tunnels and causeways designed to navigate the challenging Norwegian underwater terrain and weather conditions. A highlight of the project is the proposed construction of the world's longest and deepest submerged floating tunnel, a feat of engineering that exemplifies Norway's innovative approach to overcoming geographical obstacles. This tunnel, alone part of the route across the Sognefjord, is expected to stretch 3.7 kilometers in length and reach depths of up to 392 m below sea level, scheduled for completion in 2050. The Coastal Highway project not only aims to significantly reduce travel time across the western coast but also to boost economic growth and connectivity in remote regions.